Hello everyone, welcome to Physics Edukos. So today we are going to discuss free falling object, and before we discuss, let me tell you, we will going to discuss the free falling object in two cases, case 1 and case 2. Case 1 will be when initial velocity is 0 and case 2 will be when initial velocity is not 0. That is, an object is released from a certain distance and the object is thrown. Object is thrown from a certain distance. If an object is thrown from a certain distance, then it will carry certain initial velocity, and if an object is released from a certain height, then the initial velocity is obviously 0. So moving on to case 1. So now coming on to case 1. The case 1 is if an object is released from height h above the ground. That is, if an object is released from height h above the ground, then the initial velocity will be. Can you comment on initial velocity? If an object is released, releasing is just, it's not thrown. It's not thrown with a velocity, it's not thrown with a certain force which induces certain amount of initial velocity. No, it's just released from height h. Okay, so if an object is released from a certain height, then the initial velocity must be 0. The height is what? Height is h meters. H meters. Let the time be t. Time taken to completely time taken to reach the ground is t, and the final velocity is v. Okay, so according to the kinematics equation, s is equals to, according to kinematics equation, S is equals to ut plus half at square. Now S is what? Displacement. What is u? Initial velocity. T is the time taken, and a is the acceleration. Acceleration, okay. Displacement is the length between the initial and final position. Okay, so now S will be what? Displacement will be what? Displacement will be the height h. Okay, so height h will be equals to, since the object is released from a certain height h, there is no initial velocity. Okay, the object is carrying no initial velocity. The initial kinetic energy is 0. So the term u times t will be 0, will be also 0, and half gt square. G is the acceleration due to gravity, that is 9.8 meter per second square, and t is the time taken to reach the ground. Okay, now h is equals to half g t square. This is our equation number 1. This is our equation number 1 for the case 1, that is object is released from a certain height h above the ground. And according to the second kinematics equation, that is v is equals to u plus at, where v is the final velocity, u is the initial velocity, t is the time taken, and a is the acceleration due to gravity. Therefore, if we have to calculate the final velocity, then the final velocity will be what? V is equals to A times T, sorry, G times T, where G is the acceleration due to gravity, that is 9.8 meter per second square. This is our equation number 2. Equation number 2. Okay, the first equation gives the relation between the time and the height. The second equation gives the relation between the final velocity and the time. Now coming to the third equation, third kinematics equation, that is v square minus u square is equals to 2as, where v is the final velocity, u is the initial velocity, a is the acceleration, and s is the displacement. Here v square will be what? 2gh, and this is our equation number 3rd. This is what? This is our equation number 3rd. The third equation gives relation between final velocity and the height. Okay, from equation 1 we can conclude that it gives relation between the time and the height. The equation number 2 gives the relation between time and final velocity, and equation number 3 gives relation between final velocity and height. Okay, now I ask you a simple question. Can you plot the velocity time graph of this motion? Let's plot it. So now coming to the velocity time graph of case 1. If I have to plot the velocity time graph of this motion, then the initial velocity is 0, final velocity is v, time taken is t, and height is h meters. Okay, so we are plotting velocity versus time graph. Since it is a uniformly accelerated motion, uniformly accelerated motion, where acceleration is (9.8 meter per second square). Okay, so dv by dt is constant, that is 9.8 meter per second square, and dv by dt is nothing but the slope of velocity time graph, slope of vt graph. Now the x-axis is representing time and the y-axis represents velocity. Okay, now if I have to plot vt graph, then initial velocity is 0 and the slope is also constant, that is 9.8 meter per second square. So this is final velocity v, this is time t. Okay, this is time t, this is final velocity v, and the area this area under the vt graph will be what? Will be nothing but the height. Okay, so the velocity time graph of this motion will look like this. This is a velocity time graph. Okay, this is the time t, final velocity v, initial velocity 0, and we have taken time on the x-axis and velocity on the y-axis. Okay, if I ask you a simple question, can you plot position time graph? Can you plot position time graph? Can you conclude, can you think how the position time graph of this motion will look like? So coming on to position time graph. Now coming on to position time graph. Coming on to position time graph. So if an object is released from height h above the ground, according to the kinematics equation, according to kinematics equation, that is v is equals to u plus at, where v is final velocity, u is initial velocity, t is the time taken to reach the ground, and a is the acceleration, your acceleration due to gravity. Okay, now initial velocity is 0, so v is equals to at, and v is what? V is nothing but the slope of position time graph. Okay, so ds by dt, where s is the displacement, is equals to a acceleration is constant, that is 9.8 meter per second square, and t is the time. If 9.8 t into dt, if I shift this dt towards here, okay, then it will be what? 9.8 t dt, ds is equals to, now integrating both sides, on integration we would get s is equals to 9.8 by 2 into t square, that is s is equals to 9.8, this is 4.9 into t square. Okay, so if I have to plot position time graph, now s is equals to 4.9 into t square, so this is the quadratic equation, and the graph of quadratic equation is a parabola. Okay, time, position, so the position time graph will be a parabola. This is time t, and this is h height. Okay, so that's it. This is the complete analysis of our case 1, that is object is released from a certain height h above the ground. In the next video we will going to see case 2. That's all. Thank you.